why would I want to change from what I'm used to an image mode world? And we had one example in here about sort of like a cascading update, right? So like a container, right? You base image mode on something, right? So there's always that from line at the top. Whether that's an image you built or whether it's an image you're pulling from upstream, there's always that base, right? In my mind, a great way to use that in an enterprise or something is you guys, you build yourself your base image, which has all the basic stuff you care about, all the checklist items, all of the compliance. We didn't really touch on that, but you can do OpenSCAP compliance right inside of that container file now. And that's your base. That's your blessed, your InfoSec team has said that is the OS we need to run on everything. But then, of course, you have these other use cases. We just talked about package installations. I can't just roll that out to everything and then install my stuff with whatever after the fact, because the first time I reboot it, it's all going to go away. So what you would do is you'd then base other variations of that image on that image, right? But the really cool thing about that is, say there's some crazy vulnerability comes down the line, there's another Heartbleed or another shell shock or something, and you need to patch that everywhere. You patch it in that base image, and once that is built and passes your tests, you can test it on a deployment somewhere, physical or virtual, make sure it does the stuff that it's supposed to do. Then you just trigger rebuilds on all of your downstream images. Maybe you have to change the tag that it's tracking. Maybe you have to change it. In my case, I'm just tracking latest. But if you're doing what Matt was showing earlier, where you were tracking a specific release, you'd have to update those in all your container files. You rebuild those, and all of a sudden, they all have the update, right? And then all you have to do is schedule maintenance windows for all the machines that are using that image to pull down the latest image and do a reboot. And we talked last week about how that's really easy to roll back if necessary, which I think is another really key feature of image mode. Did you have comments on that, Matt?
One thing I want to stress is everything you just talked about is all offline work, right? Like there's nothing that touches the system. Like when you've got something, like when you think about it again, we'll go back to our Heartbleed, right? Like remediating it is like, cool. Ansible Insights told me about it and I have a playbook, but now I have to go touch live systems everywhere.
I've got to run it everywhere.
Right? The test is, okay, let's go to development environments and hope it doesn't break our app. But you got to do it all the time. You got to do it live.
Not to mention, how many times have you gone to update a package on a production system and you find out there's some weird dependency failure? There's a DNF problem. The RPM database got corrupt and you had to nuke it. Something, right? That prevents you from getting that thing done at 2 a.m. when your production database needed to be updated.
Yeah. So the other thing that lets us do, and I also have a demo, it's more of a show and tell. The demo's a little maybe not interesting.
We found demos tricky for this episode because of the time it takes to rebuild these images.
So we can trigger some stuff and then go like, okay, this is going to work in the background. We benefit from the fact that other people have been working on these problems for 10 years, because the idea of, okay, well, I just updated a container file and I have all these dependent images. Like, what do I do? Do I do that manually? It's like, no. Other people already solved this problem, and you can do something like there's a bot called Renovate that will automatically monitor all of your dependencies and push a pull request to your GitHub repo saying, Red Hat updated this image, you might want to, and like it gives you the pull request to just merge. So while we introduce new problems, we're introducing problems that are sort of solved because we're using these technologies that are actually pretty mature. We get access to a whole lot of things that we really didn't have before that we can use to make a lot of the things we would normally do anyway, right? Because you got to keep up with syncing things out of satellite and making sure you're updating your lifecycle environments and doing all that and making sure those schedules are working. Like, you don't lose a lot of that when you move to automating things through the container paradigm of an image mode host.
So now you're looking at my personal GitLab. I run this. This is a GitLab Community Edition system that I'm running. So again, right, I didn't have to pay any extra for the features that I'm going to show you here or anything like that. But this is a repository that I made specifically to build a RHEL 9 image mode system, which is why it's called RHEL 9 image mode, as you might guess. The only reason I haven't started with 10, which is what I was going to do, is there's a dependency I don't have yet on 10 for something I wanted to do. So that's the only reason I'm doing. I should be able to just change the image I'm building from to switch this over to 10 later, which is what I might do. So what I wanted to show you was the CI integration that's built into GitLab. These are essentially how those steps get defined, at least within GitLab. I don't know what they look like in GitHub, but you see there's like this definition sort of declarative language here where we're telling it, this is the script to run before we start the jobs, right? This is what image this should be based on. You might notice that I'm using a local Podman builder. I'm building 100% on Podman. The GitLab instance runs on Podman. They call it Docker in Docker, but it's actually Podman in Podman that I'm using here. And this is just based on RHEL UBI, right? So the build environment that I'm using is based on RHEL UBI instead of a full RHEL installation, which is going to be important in a second. I defined some stuff in here, which is really not all that interesting. But then we run this before script. It installs some tools that are going to be needed to actually build the container out. And then it does a subscription manager command. And you might be like, why in my build environment would I be running subscription manager to register this UBI container? Because at this point, when it's running the before script, it hasn't entered the container environment. It's got nothing to do with RHEL yet. It's just setting up the environment. And this is because when you build a RHEL image mode, or I should say a RHEL-based container in general, what it does is it uses the host that you're on to inherit the entitlement that says, yes, I'm allowed to build RHEL. We had to do that simply because of the way entitlements work on RHEL, right? So that's just kind of the way it has to be when you're building RHEL. So this is registering this host, and then all the way at the end, one of the last things I do is unregister it so I don't end up eating up a bunch of entitlements on these build containers that are just transient, that are going away. Let's see what else. We got some variables that we set, and then I log into my container registry, right? Or sorry, I log into the Red Hat container registry so I can get the image mode image, right? There is a point where I log into my registry, but I didn't cover that. Oh, here it is right above it. So, and this is because in order to push to a registry, unless it's a public registry, you need to be logged into it. These are things that I'm just setting the stage for building the thing. Then we move into this job called containerize. And you can see all it runs is a Podman build command. Now, this might look complicated, but these are just standard Podman build flags that we can pass in to Podman. You can see I'm passing in some secrets, and that's essentially so that I can pass my Podman authentication off to the build environment, right? So once you're inside of Podman doing the build, it also needs to be authenticated it needs the same Podman authentication that I had to begin with. Otherwise, it can't talk to the registries that it has to talk to. And that's why that's in there. I have some code within the container file, which will take that authentication and save it in the image that it builds, so that in the machines that result from deploying this image, I'll already be authenticated to the registries that are required to go and get the image mode images, the bootc images, so that when I do an update or something, I don't have to re-log in. That's important stuff. And then the container file itself, oh, I went up too far here. Hold on, let me get back to my registry or repository. Here we go. You can see there's a couple supporting files here, but the container file is where most of the magic happens. You can see that I'm basing this one on the upstream RHEL 9 bootc latest. Unlike Matt, who's following a certain tag, I'm just grabbing it from latest because I want this to get the latest one every time I build it, because I'm not automatically rebuilding these things. I'm triggering builds on this when I want it to rebuild. And the only real reason I want it to rebuild is to get updates at this point. I add in the Apple repo. I have a command here that is actually pulling in DNF updates. I could just wait until Red Hat publishes a new version, right? I see Matt shaking his head for some reason. Is this bad?
Yeah, that is generally frowned upon.
Okay.
So the reason why is, so you're pulling latest. What could happen, even if you're pulling latest, you could wind up pulling things that are sort of ahead of where it is, depending on what subscription you're using. Typically, we suggest you don't do that. Right? This is where, in order to make it all depends on how much control you want over knowing what's in the image on disk. So depending, because we get back to the reason that we invented satellite in the first place, depending on when builds happen, that means you could have systems that drift because of the build environment, not right in the same way that we're doing live updates on a host and something happened.
So
in the
this is actually a valid point then, right? Because I did that because I wasn't sure how often we were churning out new images, right? And I thought, well, if the image gets too old, I'm going to want to pull in updates. But if we're doing those frequently, then I probably don't need to, especially if I'm tracking latest.
So I don't know off the top of my head what our current schedule is, but it is pretty frequent for new rebuilds. But the other thing is, let's say there's an update to the repos after an image build. That means you're going to actually wind up rebuilding everything that's in the image because you're going to do a full DNF update, right? So you're actually going to drift away from what the base image was. Like you might get a new kernel.
Okay.
Right. So yeah, but again,
so I could break things by doing this, is what you're saying.
You probably, I mean, it's all within a minor release. This is the thing about which we haven't talked to the registry. We publish basically 3 sets of tags. We have the minor release latest, which is literally like whatever is 9.6. So you're only getting 9.6 updates like you would on any other RHEL repo. It's just the 200 odd packages that we bundle together and publish as the bootc image. So it probably will never really break anything.
But it's still not considered best practice, which is why it's
because it's a little harder to understand what's actually in the image.
Okay.
You said, I started from here, but then I've completely redone everything that's in there. So now it's based off of some point in time that you don't have visibility back to what was going on in the Red Hat repos. Now, if you're doing this from satellite and you're controlling that with like a lifecycle environment and you have a snapshotted version and you know what those RPMs are, then the conversation is totally different. It's all about what sources you're using and how much you care about being able to identify the contents of the package or the contents of the image from wherever you're trying to do.
If this were a signed image or something, I've now muddied it by doing the updates. Okay. All right. So there's actually a question regarding Podman versus Builda. When it comes to, you used Builda commands in your build, I used Podman commands in my build.
Yeah.
Mine, I don't know that I had a specific reason to use Podman versus Builda. It's just what I was used to. Doesn't Podman call Builda when it builds anyway?
Yeah, it does. Yeah. So there may have been differences in the past, but these days the Podman build is essentially a wrapper around the same set of libraries that Builda uses.
Right.
So it's mostly Builda will give you the ability to do things from scratch in different ways. The difference between what the action I used, which was it uses a build a bud, which is build from Docker file, is essentially identical to a Podman build. They're just different commands. It just so happens that the action I used was the build a bud, even though I think it may even be. No, I think it's called the build action, but we're not doing any of the fancy things I used to do, like build from scratch. That's how you make a 4 gig Go image or 4 meg Go image with Builda is like from scratch. And like, here's a single file, drop it and turn that into a container. We're not doing anything fancy.
All right. So that was a fun little rabbit hole there.
Yes. And yes, I am talking about package drift. That was a comment in the.
Yeah.
Right. If we're trying to control for drift, this could be a place where we might accidentally introduce drift if we're not controlling all the variables around it.
And these packages here that I've got highlighted are, I should say specifically this one, this IPA HCC client. This is a new feature that came with RHEL 10 and 9.6 that allows you to do IDM realm auto joins through insights. right? So what my experiment here was, I wanted to see if I could build an image mode image that leveraged that feature along with insights, because you then have to register with insights, that I could churn out an automatic build that would come out the other end on my home lab infrastructure, already joined to my lab's IDM domain, already ready to go. And that's actually why I need EPEL up here, because those packages are currently in EPEL. I don't think they're in the core Red Hat repositories yet. At least I couldn't find them. I think it's just the features that new at this point. So anyway, that's what I'm doing with these installations here. I'm also adding in Cloud Init so that after the fact, if I wanted to, I could do some Cloud Init actions on the first boot of this machine. And then I'm doing a DNF clean all, which is important because there's data in DNF there during this build that would then remain in the image afterward. Data you don't necessarily need to include in the image. It's also data that could cause you conflicts later, which I did run into. And there's actually some extended stuff we have to do cleanup, and that's at the bottom of this particular file. Sorry, I'm just looking at the chat. Shantanu says, I'm surprised that no one has invented a requirements.txt equivalent for RPM. I guess that's true. But do you really need one? You just do a DNF install with the list of packages you care about, right? Anyway. All right, the next thing I do here is this first boot service that we're setting up that'll do the connection to Insights, and it includes some organization and activation key details inside one of the files in my repository. That's what's going on here with this RHC Connect credentials. And then there's a system service that has to be enabled that actually does that on the first boot. I like to have suspenders when I build things, so I added a break glass user into this container build. And that's mainly because when I was first building it, I'm depending 100% on that auto join to work, which again, like I said, is a tech preview feature. If for some reason the build does not auto join, I shouldn't say the build, but when I first boot up that VM, it does not auto join, I will have no users to be able to connect to that system with. Now I could come back with Cloud Init and do that. And I may do that. I may take this out of the container file and put that inside of Cloud Init. But for now, it's in here. You don't have to do this, but I did it because when I was troubleshooting, I had a couple issues where it came up and I'm like, oh, good. Why did this particular thing not work? Oh, I have no way to get into it to find out. So anyway, that's just me.
The other thing that, aside from like emergency users like that, the other thing that could be interesting. So let's say you are hooking this up to some other sort of like you're going to hook it up to Ansible or something else for managing local state later. You could put a standard bootstrap user with a bootstrap key in all of your images so that your first automation job would be to log in with known credentials and then replace them. That way you can connect on boot to like Puppet or Ansible.
My goal was to not include any authentication credentials within the image, but that was the whole point of getting it to auto join the IDM domain. In my brain, what I would do then is have an automation user in the IDM domain that I have more control over instead of one built into the machines. This turns into technical debt. This is a thing that I would then have to manage later, right? I'd have to either come back and remove this later, or I'd have to come back and change this thing's password every so often. And that becomes a pain. And that's exactly the thing I was trying to solve with IDM. And then the next thing here is I talked about that authentication for Podman. This is the magic that makes that come in there. We have examples of this in a repository that's published by Red Hatters that have done a bunch of other CI/CD stuff. And we have a link for that in our notes. We'll have to make sure that we throw that in the description of the video today. I think, it's this one here in the notes. I'll throw it into chat here. Just give me a second.
Yeah, that's the group of people I mentioned earlier. It finds that link. We've got Ansible things, we've got Tecton, we've got Jenkins, a whole bunch of stuff. The folks are working.
These are folks who've gone deeper into the CI/CD stuff than Matt and I have, and they've published examples of how to make this stuff work. A lot of the work I did here, a lot of what you see in this container file and in that CI file that I showed earlier was basically copied from there, or at least copied and modified, right? Let's see, what else did I want to do? Oh, there was some stuff here for the timer that auto updates Bootsy. I have it turned on. You can choose to turn it off. Maybe you don't want to do automatic updates. I wanted to see how it would work if I turned it on. That's why I have this here. And then there's this last line, which is important. I talked earlier about that DNF cache. What this does is this removes a bunch of that cache data that is not removed with the DNF clean all. The reason I added that is because I started to build a downstream image from this one, which is actually over here in this repository. And all I'm doing in this one is I base it on that same rel 9 image mode. And then as an example, I'm telling it to install virtualization-host. In my brain, what I want to do is later, I want to try to build a hypervisor that's based on image mode. And this is the start for that, right? So all I'm doing is installing virtualization-host, the group, and I'm enabling libvirt, right? And it was failing on this DNF install because there was cruft left over in the base image. And that extra command that I threw in there at the end did the trick. This deletes var cache var lib DNF, and it removes var lib rhsm, and it removes var cache ld config. That cleans things up to the point where things worked again. I was able to build my downstream image. But this brings us to the point I was initially trying to make, which is that now that I have this base image, I have this rel 9 image mode image, I can build variations of that image like this hypervisor image with a much simpler container file. All I'm doing is saying, take the work I already did in that one, bring that in and do these extra tasks. So now I could do extra things in here, like set up libvirt networks or something that I wanted to do automatically as this thing was being built out. And then I could theoretically deploy a dozen hypervisors that are all based on the same config, which I think is pretty powerful. And then the updates and management for these things become update the images, reboot the machines, and up you come, right? So there's a lot of potential here.